Let us look at proposition number 25 of book 6 of Euclid's Elements. Proposition says to construct a figure similar to one given rectilinear figure and equal to another. Equal means the areas should be equal. Okay, so here we are given ABC, a triangle, and we have to create another triangle which is similar to ABC, but having an area equal to the area of the figure D. This is a big thick construction. So please tighten your belts. Okay, the first thing we do is draw a parallelogram on BC equal to the area of ABC. Do we know how to do that? Take the midpoint of this, draw a parallelogram by drawing another line through C parallel to AB. So this is, we have already seen in one of our previous propositions. First, let's join these 2 points. Yes. So that we get 2 triangles. Again, this construction also we have done. We have joined this. Now we are going to create another parallelogram along CE equal to the area of this triangle. So first we create a parallelogram here equal to this triangle. Again, we know how to do that. So I'll directly present it. Now we create the parallelogram along C equal to this parallelogram. I'm skipping the various steps because it is too big of a construction. Okay, so this is our parallelogram along CE equal to this parallelogram. Next, we again extend this parallelogram by creating another parallelogram along this line equal to the parallelogram equal to this triangle. That would be this. Again, we have taken a midpoint of this and drawn a parallel line through this point. And now we create a parallelogram along this line equal to this orange polygon. So this is equal to this. So we have created a parallelogram BE equal to ABC. We have created a parallelogram CM which is equal to the area of this complete figure. We have to create a triangle which is similar to ABC, but the area equal to this. So for that, we have to figure out the mean proportional of BC and CF. Again, we know how to do that. So we draw the line segment which is equal to the mean proportional of BC and CF. Now what? Now we copied this angle CBA at G and ACB at H, and we draw it. So here the area of D is 20.23. I'm using GeoGebra feature here. And the area of the triangle GHK is 20.23. The angle ABC, we copied it to G. Angle ACB, we copied at H. So naturally, which means that the third angles will also be equal. So we have created a figure KGH which is similar to ABC and whose area is equal to the area of the given figure. It's not enough for me to just show you that using GeoGebra feature, showing you the area, right? I should be able to prove it without that. So we will look at the proof. Now, see the fun of drawing it strictly as per the proposition. If I change this triangle, automatically everything changes, but the areas remain the same. Yes. Now, to change the area, I change the given figure. See, both of them always remain equal. Now, let's look at proving this, that the areas are actually equal and this is similar to this. Let's take it step by step. Now, BC is to GH as GH is to CF. Why? Because remember, we have taken GH as the mean proportional to BC and CF. BC is to CF is equal to triangle ABC is to triangle KGH. On what basis? Again, we have seen a proportion. If three magnitudes are proportional, then the first is to the third as the figure on the first is to the similar and similarly situated figure on the second. We also know BC is to CF is equal to parallelogram BE is to parallelogram CM. Basically, parallelograms are proportional to their sides. Here, BC is to CF, BC is to CF. So, they have the same ratio with respect to these two. So, we can say triangle ABC is to triangle KGH as parallelogram BE is to parallelogram CM. If we take the alternate ratios, we get triangle ABC is to parallelogram BE, triangle ABC is to parallelogram BE as triangle KGH is to parallelogram CM. Triangle ABC is equal to parallelogram BE, we know that because we constructed this parallelogram equal to this triangle ABC. So, which means that triangle KGH will also be equal to parallelogram CM. Then only the ratio will be equal. But we know parallelogram CM is equal to figure D based on our construction. So, which means triangle KGH is also equal to figure D. That was as far as the equality of this figure and this triangle was concerned. Now, we know corresponding angles are equal because this angle we copied at G, this angle we copied at H, which means the third angle is also going to be equal. And not only that, we also know that BC is to GH as GH is to CF. So, which means triangle ABC is similar to triangle KGH. So, that is proposition 25 of book 6 of Euclid's Elements. The proof itself is pretty straightforward. Main work is actually constructing all this because a proposition is being applied multiple times. Here again, proposition is being applied multiple times. Okay. Plus, there are additional constructions which I have not shown. That is finding the mean proportion. It is there down. So this is BC, this is CF, and this is going to be our GH. That is our mean proportional. The construction is quite comprehensive, and which means basically that you need to be very careful. Again, you change this, automatically everything keeps changing accordingly, but the areas remain the same. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and in case you think somebody else can also benefit from it, please do share. That's it for now.